Hello there, it's Alana, and I'm here to help you with 9.1 number 47, which is actually not really a hard problem. It's just kind of tricky because you have to think about it in a different way. Of course, in statistics, we're always trying to apply what we know to a new situation, a novel condition, and that's what we're going to do in this problem. All right, let me click on the example. And it says, by how many times does the sample size have to be increased to decrease the margin of error by a factor of 1 over 10? Okay, hold on. Let me pull up the notes for that section. There they are. Okay, so these were from our lectures. And at the very end, one of the last things we learned about was sample size. There's a formula for it. Actually, in section 9.1, there's a couple of them. There they are. Okay, so you see this one is n equals 0.25 z over e squared. Which is the one I'm going to play with. It honestly doesn't matter which one we play with. It would work no matter what we did. So, oops, makes no difference. All right, so let me go grab my other one. Oh, I guess I'll just do a new sheet. Okay, so here's what we're going to do. I want to write down what the formula is. Z. It actually doesn't really matter about most of this stuff, but that's okay. Alpha over 2 over the error squared, right? So what they're wanting us to do is they're wanting us to change it so that the error is no longer the error. It is shrunk by 1/10, if I'm not mistaken. They want to decrease the margin of error by a factor of 1/10. Okay, so that means that instead of having error down here, I want 1/10 of my error. Okay. All right, now this is really just going to be some algebra trick, and then you'll see what happens, because it's the 0.25, right? And then if I want to distribute the squared, right? Well, I could do it that way. Well, let me go back. Let me just give you a reminder real quickly. Okay, if you have, let me think, a fraction, and it has 5 over, let's say, 1/10, just for the sake of it, right? How does that really work? Well, it's 5. Oopsie. I don't know this symbol off the top of my head. I'm going to have to do it longhand. Oops, the symbol palette's gone. All right, there it is. It's 5 divided by, there it is, 1/10, correct? Right? Because 5 is the numerator, 1/10 is the denominator, so that's really 5 division symbol, 1/10. Okay, but that really means it's 5 times, oh my goodness, if I could do this right, 5 times 10 over 1, right? Because when you divide by a fraction, you flip and multiply, right? Well, that same operation is going to take place down here, right? And let me make it a little smaller. So I don't really actually care that much about the 0.25 and the z and all that stuff. What I really care about is what's going to happen to this 1/10, right? And actually, you know what? Let me mention to you guys right now that what it really is really e over 10. Because when you multiply by, that's another thing that you might have forgotten somewhere along the way, that when you take something like, I don't know, x, times, oopsie, there we go, times 2, or let me do it this way, 1/5. What that really is x times 1 over 5, which, who writes x times 1? Nobody, right? So it's x over 5. So this down here is really the same as e over 10, right? Which you don't have to do it, but it just makes things a little bit easier algebra wise. And again, this problem is very algebra. All right, so this is 0.25 times, and then I'm just going to leave all the stuff inside the parentheses because I don't really care. But what I want is this guy in front, and then he's divided by, there he is, and then e over 10. And then that's all squared in a minute. Okay, so I'm going to go down a line so we have room here. So equals 0.25. And then we know that this is really going to be flipped and multiplied, right? So we'll take z and we'll do times, and instead of e over 10, it'll be 10 over e being the error. Okay, so you can see what's going to happen, right? So you got your z over your e just like you were expecting, right, in the original formula. It's just what's happening to this 10? Well, here, let me write this out. This is 0.25 times, and again, there's a lot of algebra-y ways we can do this. This is just the way I'm thinking of right this second. But I can say, okay, look, this is really z alpha over 2 over the error. I can shift that error and kind of shove it under here because it's in a numerator. Or here, let me put it this way. Here, times 10 over the error squared, right? Okay, so there's the z over e part that we had in the original formula. But what's going to happen to this 10? I can move it out and say, okay, that's 0.25, and then z over e squared, which is the original formula from the notes, times, and I'm just going to put the 10 squared out here. And then, of course, what is 10 squared? Everybody knows that's 100, right? So this part right here is actually what they're asking about. They're asking, like, this, all this stuff over here is the original formula. So how did it change? When we put in 1/10, it flips up, right, down here. We did all this work just to kind of show you how that happens. But essentially the 10 ends up being in the numerator, right? And then you take it out of the numerator and square it. And there you go. So it would be a factor of 10 squared. So 10 squared is equal to 100 is how the sample size changes, right? So n originally, if you just have it without the 1/10, is z over e squared. When you put in 1/10, you want to shrink that error by a tenth. It causes the entire formula to, here's the entire formula, right over here, to change by being multiplied by 100. And of course, there's nothing magical about the numbers we picked. I mean, 10 could have worked for any number. You pick, 6.23, and it would do this. You just end up with 6.23 squared. But this is why. It's really this same property up here kind of on steroids, right? It's the fact that when you put a fraction in the denominator, it ends up flipping into the numerator. And then we just squared it because that denominator is inside a parentheses squared. So you have to square it because that's where it's located in the formula. But in the end, all you're doing is a little math trick. Taking the fraction out of the denominator, flipping it, and that means the bottom number ends up in the numerator, and then we square it because our formula has it squared. And that's it. All right, so I hope that helps with that one. Let me double check here because I was doing this all flying blind. Now they're showing you a different formula. That's actually a formula from a later section. I mean, it still works. And they do this whole E2 equals 1/10 E1, which is more technically correct. They're being more careful about how they do it, but I'm just not bothering. Right? So that's another way that you can explain it. Right? They're setting up, E1 is your first error, E2 is your second error, yada, yada, yada. But the idea behind it is still the same. You're still going to get 100. See, they've got the 10 squared, which is 100. All right, I hope that helps with that one. My method's a little bit different, but I kind of think it's easier to understand, but that's maybe just me.